every single week, we're going to have a new theme that's kind of science themed. And this week, our theme is Earth sciences, but specifically data that's taken about Earth from satellites in space. So all our labs, we're going to be working with NASA data and satellite imagery. So even if I don't talk a lot about that theme now, realize that we're going to explore that theme a lot in our labs. And that is to say that space sciences also includes Earth. Earth is a planet. And one of our projects is going to be Earth-based and climate science-based in terms of our last 2 weeks. Okay, so in this course, we're going to learn software engineering while learning space sciences all at the same time. I hope that it'll be a little more fun than just kind of studying programming on its own, because really where programming gets exciting is when you actually get to apply it to something. And most of the learning is by doing in the labs, not by reading or listening. We're more here so that we don't have to spend all day facing a computer, and they're recording, so we'll be able to have these videos for you to watch later. But everything I say is also written in the course textbook. The lectures follow the textbook exactly. I'm writing the textbook and then the lectures in that order. And the textbook has some additional chapter exercises. So in the lab, you can follow through the textbook and do those exercises. And every week has what's called a Jupyter notebook, and we'll learn more about that later. And anytime you see a notebook problem referenced in the textbook or the lecture, as soon as the problem is brought up, that means everything up till then you have the knowledge to try that. Before then, you might not have the knowledge to try the problem. The notebook problems generally take a little longer than the exercises, but we'll attempt all these problems in our lab sessions. And it may be, depending on the week, you might be able to solve all the notebook problems here. If you don't solve all the notebook problems here, they're homework. So it's a good idea to try to do as much as you can in lab. There's plenty of time that I think we'll be able to do it. We're also going to be working together a lot. This is also true when you're programming for a company. You're not just working on your own. You might work on your own for a little bit. Every day, often, everyone gets up and shares what they did yesterday, what they're going to do tomorrow. And often, once you do a little bit of work, you show a colleague or a boss to do what's called a code review, where they look at your code, they give you some advice, or maybe you meet with a colleague or a boss and you say, hey, I'm having trouble with this, I have this idea, or here's my idea, here's how I think I'm going to do it, and they give you some feedback. So we'll be doing that in the lab sessions as well. So what is software engineering? Softwares build and design ways of using computers to help them solve real-world problems. They work in teams, and they interact with other software engineers, also with users of the software, if there are users besides you yourself, and also with entrepreneurs. Many of them are entrepreneurs starting businesses themselves. They work in a variety of fields, so software engineering is kind of meaningless because software engineering for what? They work in medicine, biology, ecology, music, art, consumer products, finance, and much, much more. So when you check almost every business that you can think of, from a restaurant to a gallery, an art gallery has a reason to interact with a software engineer or actually have software engineering experience at them. So to learn software engineering, we need to not just become familiar with computer programming, but also with collaborating with teams. That's the engineering part, besides the software part. So there's often full courses when you study to be a software engineer in college about how to organize a team of workers, how to distribute what people are doing, how to talk together, and also you have to be familiar with reading other people's code and brainstorming solutions. So there's going to be a lot of reading in software engineering, either of other people's code, where you're like, what is going on here, or actually of things online in terms of figuring out, okay, someone wants me to design a piece of software to represent this concept in biology, I better learn a lot about that concept in biology or see how other people have done it in the past. So software engineering skills aren't dependent upon a specific computer language or using a specific set of tools. You might see a lot in high school. There might be a course in JavaScript, or there might be a course in this language or a course in that language. If you study to be a software engineer in college, they don't necessarily say this course is in this language. They say this course is about this concept, say working in teams as software engineers. And it so happens that during the course you use the language Java. But the course doesn't necessarily always teach you the language because the course isn't about the language. That said, you might hear a software engineer who's been working in the field for 15 years rattle off a bunch of different computer languages, and when you learn your first, it's really overwhelming. You're like, how did this person learn 15 computer languages? The good news is that mostly, once you learn one set of tools, when you go to learn another set, it's like riding a different kind of bike. You already know how to ride a bike. Someone gives you a different kind of bike. It might be a little taller, it might be a little shorter, but you know the basic concepts of riding a bike, and you'll be able to do it. The reason why they know so many tools is literally because they're being paid to learn those on the job. Every time you move a different job, every time you work with a new client, you might need to pick different tools. So we don't judge a mechanic of a car because a mechanic might need to use 30 different tools. They know the concept of fixing a car, and they know how to pick the tool for the job. And so in this course, we're going to focus on the tool of the Python computer programming language, but we're also going to learn a few other tools along the way as well. And that will give you the general, like, I know the basics after this course. So don't get overwhelmed. If you've learned to speak a natural language, you can learn these tools too with time and practice. I actually think you guys are all geniuses based on from my interviews, but you don't have to be a genius. Bad news or good news. It's something that you can learn. It's a learnable skill, and that's why we have almost every lab session that we have, we're going to have 3 teachers with you, so you'll have plenty of opportunity to have a lot of help. So I already mentioned a bit about the schedule. Okay, so what is space? So space can be a lot of different things to different people. In this course, astronomy and astrophysics, we have chemistry, mathematics, physics, and in recent years, computer science. And space science includes studying galaxies, our own Earth, the origin of the universe, planets, stars, asteroids, satellites, human space exploration, and more. So this course has the theme of space, but I could have just as well had the theme of art or had the theme of anything else. We're using space to illustrate the concepts, but yeah, if I run this course again next summer, hoping to, we might even have the theme of biology instead, for example. So we picked space because that's my favorite field. I have a doctor in astrophysics, a doctorate, and so I thought it'd be easiest to start with what I know best, but we could have picked any theme. So for our theme, it's space, and we're doing projects. So each chapter contains one space theme. This week is the Earth, 4 core computer science topics, and 4 guided explorations of the theme. That's 4 labs. So this is going to be the same thing every week. So you'll see this pattern over and over again. So I shared with you guys the textbook already, which I'll remind you when we have a lab session. But basically, you can edit the textbook yourself by highlighting and creating a comment. So if anything confuses you, do that, and one of us will respond. If you think you can explain it better, or if it's unclear, explain it in a comment for your classmates, and then we'll add that to the text itself. And if you end up adding any text or explanation, we'll credit you as a co-author of the textbook. So that's some incentive. You can say, I co-authored a textbook on software engineering. So yeah, it's really up to you, and if you have a good explanation, I think one of the great things about learning something new is as soon as you learn it, if you have that aha moment, you're so close to it, you can help share that aha with your classmates and with other people. Once you know something really well, say you've been playing the piano for 13 years or you've been gardening for a long time, you don't remember the aha moment as well. So if you ever have an aha moment and you're like, oh, if only I had had it explained like this, go ahead and put that in a comment and we'll try to add it to the textbook to help others get that aha moment. So this week, we're going to learn how to use the Python interpreter. We're going to use a little bit of another language and another way of interacting with a computer called the bash console. The more advanced usage of bash will come a little bit later. We're going to learn to launch Python, and we're going to learn to use a Python notebook. And these are all kind of mechanical tasks. These aren't necessarily things that are conceptual. These are just learning how to click here, click there. Yeah, you have a question?
It's like, say, bash and CSH and most program cells are basically the same if you don't do advanced things. So
That's
really say specifically bash.
Yeah, that's a good point. So in this course, we're going to be using specifically bash on IPython Anywhere, but we'll explain as Nico, who's had some experiences with this, just like I mentioned before, once you learn one particular tool, how to ride one particular bike, you may notice that even though there's a lot of tools that have different names, for example, TSH or other consoles or shells, scripting languages, that they're very, very similar in many usages. Yeah. Here, let me see. Yeah, here's a good thing. Okay, why don't you? Let's see if this works. Yeah.
Okay, I would say it's like using Firefox versus Chrome. They're basically the same, there's just a few minor differences that one can learn to switch.
That's a good point. So maybe we'll add something like that in the textbook in a comment if you want to add that. But yeah, many of these things can be as similar as using Firefox or Chrome or any Internet Explorer, any web browser. Some are more close than others, like Firefox and Chrome are closer than, say, Internet Explorer. But you can do the same basic tasks in them, and once you learn one, it's very quick to learn another. So we'll also be learning about numerical types, operators, expressions, and control flow. If you've done any computer programming before, you might have heard of some of these concepts. We're going to illustrate them using Python, so even if you know it in another language, it's good to learn Python because we're going to be using it in the course itself. And there'll be an exercise illustrating each concept. And then again, if you do happen to know some of these things already from your other course, some of the exercises are much more advanced. So when you actually go to apply that knowledge, you'll be thinking about not only how to use numerical types, say add integers together with operators, but which integers you want to add and how. So what is Python? Python is a computer programming language we can use to automate a variety of tasks on our computer. It can help us do tasks that would be otherwise impossible to manage by hand. So if, for example, I wanted to send everyone in my address book a different email depending on their birth date and also send them a random number that was going to be used as a password. If I had to do that, I have probably 1,000 people in my address book, be a long time. And then how would I pick that random number? Can you pick a random number? Yeah, any number. 10. Yes. That's a good point. So even when humans try to pick random numbers, we can do an exercise with this at some point. But if humans try to pick random numbers, we're generally pretty bad at it. And this is one of the reasons why with even the lottery, a lot of people end up randomly picking the same numbers. And what that means is that if often with a lottery, that if a lot of people pick the same number, then if that number wins, the prize is distributed among everyone who picked that number. So you win a little bit less money. So in Massachusetts, there was a case of people using computer programming and numerics to calculate numbers that people didn't often pick, and picking those numbers, because then if they won, they wouldn't have to share the prize. And they ended up automatically buying a lot of lottery tickets to pick these kind of unpicked numbers, and they actually kind of scammed the lottery until they changed the rules so that basically what they changed the rules to be was that you could, at the kiosk, when you bought the lottery ticket, ask them to print you a random number. And then when you asked them to print the random number, they used a computer to make the random number instead of a person. And that meant a lot more people were picking random numbers. So then the prize was distributed evenly again, and the people who were betting on the unpicked numbers didn't make money anymore. So random number picking is something that computers are good at, doing a lot of tasks at once, something that computers are good at. So in biology, for example, say we're analyzing some DNA samples, I can give you a series of ATGC, but pretty soon it'll be even worse than me lecturing at 8 a.m. You'll just fall asleep, whereas a computer doesn't fall asleep. It'll crunch all those codes and be able to maybe find patterns in them. So there are various versions of the Python programming language. Throughout this course, we're going to be working with Python 3.5, so make sure you're using the correct version. The good news is that we're all going to be using pythonanywhere.com, and the login is in your envelope on that first sheet with the icebreaker, and we'll sign into that during the lab. On pythonanywhere.com, actually, maybe I'll just show you guys. So we're not yet. We will be doing that in the last part of the course. The good news is because there's a lot of different software installations that we have to do, and we want everyone to have the same software installation. The other good thing about Python Anywhere is that it's quicker to collaborate, because I can, for example, view as any of you, and so if I need to help you, it's very easy. So when you log into Python Anywhere, you'll see here, you can start a new Python console. We're using 3.5, so you would be able to click 3.5. You can start a new IPython console. You can click 3.5. You can start a new Bash console. You can click here. And we're also going to be able to, later in the course, we're going to be running web applications. And you're able to do all this without having to install any software on your computer. We are going to, for the first 3 notebooks, we're going to use 100% Python Anywhere. So the other nice thing is if you have a tablet or anything like this, or on any other computer besides your laptop, you can also work on your exercises. In the library, wherever, you can work on it. For your projects, we're going to want to install all this software ourselves. It will take, depending on the setup and the errors that we have, anywhere from 10 minutes to 3 hours to fix things. So iBouquet can give an example.
So I was using Python 2.7, so for this class I was updating to 2.5.
3.5.
3.5, but because I updated to recent one, which is 3.6, so I had to downgrade it. But then what happens is the packages change name, then there's a conflict when you are trying to downgrade it. So whatever you do, it doesn't work. So what I did was I just removed the Honda, then I had to upload it, then I had to upload the packages, and this, so it's good to
Anyway, when you're managing your own software, and especially if you run Linux or run another machine, you spend some of your time, instead of learning concepts, just installing things. And that's part of the fun of learning how to be a software engineer, is learning how to install things, and we will spend part of the course doing that. But for the first part of the course, we want to just be able to run Python without installing anything and run it from anywhere. So for example here, if I click on Python 3.5, it'll launch a console. And then I can say print hello class. So we'll be able to work right away with the various, and also we have the first chapter's Python notebook, Jupyter notebook, and so you'll be able to see here, if you click it, we'll be able to learn and already use a variety of NASA problems and software and display satellite images right away. So that's all accessible from Python Anywhere, and you have the login. So this is what we're going to be doing all our labs in. And you can work on this from anywhere that has an internet connection. So the textbook does contain instructions to install on your own computer. And we will be doing that in a few weeks. So if you're impatient, you're welcome to try to already do that. If it doesn't work, Python Anywhere. And Python Anywhere is where we're going to be putting all the exercises. And what's also nice is that lets you collaborate with other people. So you can share the same console and see it both on your screen. OK, so what was it that we just saw? An interpreter is a program that reads and executes computer code. A console, sometimes also known as a shell, is a user interface for interacting with a computer. So we already just launched the Python interpreter, and we gave it some code to execute, print, hello Python interpreter. What does print do? Well, with most things in Python, we can also ask Python itself. So let me bring up that console again. And I'll just leave that up this time. So in Python, you can type help, and in parentheses, what you want help with, and it'll actually tell us some more information. So here it says help on built-in function print in module built-ins. So built-in means it comes with every version of Python. It's not something that you have to install extra. And it says it prints the value to a stream or a sys.standout. It has optional keyword objects, which we're not going to need right now. Print is a more simple command, but if you ever have any questions on anything, you can kind of type help and then get more information on it. And we'll talk later about where to go with more advanced questions, but this is a good place to start. Particularly later, we'll learn more about functions and arguments, but even if you write your own functions, sometimes you'll forget which argument is which. Say the first argument is the drink and the second argument is the food. You don't want to mix up the drink and the food and pour the food into your mouth. That would be bad. So if you're like, which one's the drink, which one's the food, you can look in help and see the documentation, and then it might say the first one's the drink, the second one's the food. So what is the IPython console? IPython is one console available for Python users, and it's the one that we're mostly going to be working with in this course. It's basically a Python console, but it has a few extra features. So instead of the Python console, if we pull up the IPython console, a few extra things work in IPython that don't in Python. For example, you can put a question mark after anything to get the help, which is a little bit more of a quick way to do things. Then when we learn more about the bash console, you'll learn that in bash, there are a few commands that tell you about the file system. For example, lists. We'll learn ls. And many of these, yes, we'll learn about a lot of these. So one is ls, which is like list, and that shows you all the files that you have. And this isn't a Python command. This is just IPython trying to help you out, because sometimes what you'll want to do from Python is open a file. Like let's say open readme.txt. So I want to open that file. So I'm going to do open and I'm going to set that to be a file. And then I'm going to print the file and the lines in the file. And we'll see if that works. So this is something that this file says here. And it's about the Python Anywhere system. The thing is, to open this file, I needed to know where it lived. And that's why it's useful in the IPython console to be able to use some additional commands that aren't just from Python itself. So it's like a Python assistant, almost. It helps you explore and write not only Python, but also other commands.
You didn't mention this, but you did it. Pressing tab will auto-complete something you're typing in, which is, I use all the time, and it's used in like almost all shells.
That's a good point. So this is the other good thing about in IPython, that we can press tab to autocomplete. So when I went to type open, I typed R, and then I push a tab, and it gives me anything with R. And some of those things are in Python, and some of those things are in files. And we'll learn more about which is which. But the reason to already start out with using IPython is that it has some extra interesting features in it, like the tab completion. So for example, I think the tab completion is a great thing to highlight, Nico. So say I want to print. If I type just PRI and then I tab, it kind of guesses that I want print. So if you kind of remember, oh, I know this started with an A. Let's see if it knows anything that starts with A. So we have all, any, as, or and. So it'll help you try to figure out what you can do from there. And this is all stuff that isn't built into Python. This is IPython, which is just trying to help you program in Python and remember things better and be quicker about it. So even if you remember nothing, but just the stuff that we learn in Python, already use the IPython console, because as you go along the way with the tab completion and other things, you'll be able to find it more and more useful. And again, on Python Anywhere, you don't have to install anything. It's just under the IPython section. So even though you can, this is what you'll get if you install just Python itself, but we're mostly going to work with this IPython. Okay. So we've already seen a little bit about this bash console. Most people who interact with computers find files by clicking around, click on a folder, or searching from the search bar. You might go, I remember this file, it's called README. A more convenient way for programmers is something called a console or a shell, or a terminal window, or just a terminal. These sometimes have subtle differences in meaning, but you'll often hear an experienced computer programmer use any of these terms to mean this. These shells come with their own languages and commands. One example shell commonly used is the bash console. This is the one that we're going to work with in this class. So why use this totally extra thing? So the bash console, instead of using Python, uses the bash language. We're, in this class, mostly going to just use the bash console to launch programs by typing their name and not worry about the bash language. That can be something that we learn later. And we don't use Python every time, even though everything we can do with Python, we can also use bash. Because the bash console is how many people launch Python in the first place, and many tasks having to do with computer files are quicker, because you're able to use programs built into your computer very quickly.
Another thing that is really quick with bash, that's almost like automation.
You want to say something?
I generally use bash on a daily basis for all my interactions, and one thing that is more useful in, well, actually I use ZSH technically now, I think, but one thing that's more useful in Linux shells compared to, say, doing it in a file thing is even type, say, to move all the files starting with a certain thing, you literally just type mv, then type the first parts of the files, then an asterisk, and that will have all the files that start with that specific text. and then you say where you want it to move. And basically it automatically will select all the files. It's really useful. There's a lot of things that are done in one command in the bash shell that are really, really quick and convenient.
So we'll get to learn how to do that in Python as well. The thing is, in Python, it takes a lot more time. So mostly anytime you're doing something with like a file in a second or launching a program, doing it in bash is a little quicker. Anytime you're doing something that might take more than a line or something more complicated, using Python is quicker. So most programmers know a little bit about both. We're going to know more about Python than about bash in this course. But I'm going to teach you a little bit about bash because of those useful features, because you'll run across it in your internships, and because specifically we're going to have to install some software, and it'll help us install that software. So again, luckily we can just go to Python Anywhere and click bash, and it'll launch a bash console. We don't have to install anything. And here, we can type ls, and that will list all the files. And we see the same files that we did in our IPython shell. So it has many similar features to IPython. The thing that we'll end up doing is using a package called pip to help us install Python software. So I'll run it without any arguments, just so that you can see. And we can see some commands here. We're going to be able to install software. So when we go ahead and work with software from NASA, we're going to use the bash console, and we're going to use pip to actually install this software. And what's nice about this, even though it seems like one thing to learn, more to learn, is that you're mostly able to install new software with just one little line. So instead of having to visit a website, click, double-click, install, press OK, press permissions, launch, there are all these different steps. We're mostly going to be able to just paste a command here, run the command, and like a Harry Potter spell, it'll install. So we'll get used to using this as well. I think I need to keep moving. If you have I'll take questions but not comments, just because I don't want us to stay too long. Yeah. So it's more just because I want to get through everything that we need for the lab. But if you have I know, it's very exciting. I'm excited too. You'll be more excited when you do the lab, because we're going to see satellite images today, which I'm excited about. But to do that, I had to show you a little bit about bash, because we're going to use bash to install the software that we need. I could have installed the software for you guys, but I decided that we're going to learn how to install software already, because that means that when you find software that you find useful for your project or whatever, you'll know how to install it for yourself. And so it's a skill that we're going to learn today, is how to install that software. So I mentioned that we're going to be using some NASA software. So this is basically the command that we're going to copy and paste into the bash shell to install that software. So we can also see that instead of clicking on Python Anywhere and launching Python, we can just type it here. And there's Python. So then I can do the normal print hello thing, etc. Then I can Control D, and that'll exit me out of there. And then, pardon? So we can try Control C. Control C might also work. So we can see that Python takes that as a keyboard interrupt. So often when you're loading a program, the thing is that the interpreter, you might be running a computer program in Python and not want to exit out of Python entirely, if that makes sense. So I think that this will work. Well, true. This might break things. Print hi summer app space. Okay, so this is we're going to learn about this later, but this is a while loop. And while this is true, it's going to print this. So it's going to print this a lot. So let's see. oh my gosh, this is a lot of things. And so I'm going to push Control-C. Oh, we exceeded our I/O limit. Okay, never mind. I didn't even get a chance. But this is an example where we would be able to push Control-C, get out of that program, but it doesn't get us out of Python entirely.
Well, most programs use Control-C.
Yeah, so Control-C is a good idea to start out with, but with Python, we're gonna Control-D out of there. So let's go back to our Bash console. And then this time, I'm going to type IPython instead. So we learned how to launch Python, Control-D. Now, here's IPython. So it's, instead of clicking around, basically anything that you can do by clicking on your computer, you can also do very quickly in the Bash console. Just to use an example that Nico used, so let's see. Say I wanted all the files that started with chapter, I wanted to move them to a directory called my site. So I can move all the files that start with chapter to the my site directory. And then now I can look in my site, and there's all those files. So I'm going to move those files back. And we'll learn more about this later. This isn't something that you need to know right away. It's more that there are very quick things to do on your computer that you can do like this. So one thing that I did just today is that I have a bunch of things on my desktop, and I wanted to move all the files on my desktop to here so that you guys didn't have to stare at them. So what did I do? I launched on my very own computer the Bash console, and I did that move. So once you learn some of these commands, you can already use them at home and on your computer, not just on Python Anywhere. And we'll go over that later as well. Okay, so asking for help. Coding is mostly an open book exam. Unless you're interviewing for a job, you have the help of the internet and your colleagues. You can ask on the Slack channel. If you're stuck, try searching the textbook. See if you can look at some example code, either that's been written previously. Ask one of your friends in the class. We're all going to get to know each other very well. We're not always going to be working with the same person. We're going to be mixing it up. If you're getting some sort of error, say it says blah, blah, blah error, copy and paste that into Google and put quotation marks around it. And then see if anyone else in the world has had that error. Probably 99% of the time someone has. And that's where reading comes in. You can try, if you're at home, if you're no longer in this course, you can try a forum or stackoverflow.com. And Stack Overflow is a place where programmers ask a lot of questions. So there are a variety of ways to ask for help both in this class and after this class. So asking good questions, we're going to have a session, I think, now in the lab about how to ask good questions. There's certain polite ways to phrase it. And now what polite is on the internet is different than what it is in reality. So you might not know what's polite for a software engineer to ask at first, but don't be afraid to make mistakes. Stack Overflow, as I mentioned, is very popular. Users should ask their question in the right way so that it gets attention from the community. I don't know if you've ever had a friend like ask you something that they could just Google. Has that ever happened to you, where they're like, you're like, why don't you Google that? So if you ask a question in a way that maybe someone's already asked the same question on the same exact site earlier in the day or the week, or it's easy to search, people will say that's not the right way to ask the question. The first thing that you should do when you're asking a question is do as much work as you can to make sure no one's answered it before. And then the second thing when you're asking a question is to be very specific. And Ibuke has done a lot of research on this, and she's going to give you guys advice about asking questions. The third thing about asking questions is even if you don't plan to ask anyone else or ask a forum, pretending like you're going to and writing up the whole problem will sometimes solve it for you, just because you're thinking through the problem when you're preparing to ask a question. And you might be like, oh, I understand it now. So pretending like you're asking a question is a good way to figure out bugs. So we saw this a little bit already. It's called a Jupyter, or sometimes you'll hear IPython notebook. It's a way to let us combine code writing and execution with text, math, plots, and other media. Jupyter notebooks are kind of like IPython, but they have even more features. They function as a text editor where you can edit and save your code right there. And it's what we're going to be using to specify and solve the notebook problems, which are throughout the chapter and the lab. And so I'll give you guys an example of that as well. I opened it up before, but we'll open it up again. It's in the files, and this will be in all your home directories already. So here, this is our first problem. The first thing we have to do is import some software that we want to use and set some variables to make sure that it's easy to use. And so how you run this is I can either go Shift-Enter, which I'm going to do right now. Then it's running, and you see there was a little dot there when it's running, and then when it's done running, it outputs a number, which is, it helps you tell which order you run things in. I can also click on this and go to Cell, Run Cells. So you also have the option of running it. Here it ran again, so this time it's 2. So now this time we're going to execute the following code, and you'll get to do this yourself today. So this code is going to let us see a real satellite image from the Landsat 8 satellite taken February 2nd, 2017. And this satellite passes over each point on Earth roughly every 16 days, which is really cool. That also means if you pick a random date, maybe the satellite didn't pass over this latitude and longitude at that date. So that's sometimes where you'll get an error. I happen to know that the satellite did pass over this latitude and longitude at this date, so we can display, oops, uh-oh, I got an error. Let me take this out for a second, and then I probably have to, oops. It's called the demo effect. It's well known in software engineers circles that if you go to demo something, sometimes it breaks exactly then. Okay, so let's try this. Okay, so now it's running. And then here we have the actual image itself. So the nice thing that you can see about this is that we have text, we have code, it's all in the same place. So we don't have to go back and forth with a console. And we'll be doing most of our big problems throughout the course, the lab problems that are a little longer in these notebooks. And it'll save the image right there. So then if you want to later save this image, you can go to Save Image As, and then I will be able to save this on my desktop, for example. And so once you guys get images that are really cool, do save them and send them to the Slack channel, especially if you find like certain things in images, like you see a whale or who knows, I don't know what you would see. But you can save any image that we get to do here. So what we'll learn about in the textbook and in the code here are various numerical types. We're going to be working with latitude and longitude here. We're going to learn about variables. We're going to learn about assignment. We're going to learn how to calculate latitude and longitude. If you're given a latitude and a longitude and you want to find 115 miles away the latitude and longitude, we're going to learn how to execute a formula. And instead of having to compute this by hand, we're going to write some Python code to do that. We're going to learn about if-else conditionals. We're going to learn about while loops, about for loops. And then our final problem for the week is really cool. So we're going to pull some satellite images and try to figure out how many clouds are in them. And so I've written a little kind of guess at a function that estimates the amount of clouds by figuring out like how much white there is versus how much black. And we can always improve this function. But we are going to figure out some images from California. So maybe you can pick a desert or pick wherever. And then we're going to compute the average cloud cover there. We're going to use that code that we had before to find images around it. So every image is 115 miles by 115 miles, but we're going to want a giant square of images. We're going to learn how to figure out groups of 3 months of dates automatically. And then our final problem is going to be computing the average cloud cover around the area that you pick in 3-month chunks for a couple years. And we're going to see if we can see the drought ending or not. So it depends on the area, and maybe you won't get the answer that you expect. Maybe there'll be some errors. So the good news is that you'll be able to view the images that you get, so you can use that to debug. And if your code's telling you that there's a ton of clouds there and you look and there are no clouds, then that's a different thing. So this is an example of a real-world application. This is real data. People are trying to do this sort of analysis, other people. But estimating the number of clouds is probably not the easiest thing. So in our little algorithm, what we're doing is just guessing by the number of white pixels. But imagine if I were to do that, estimating the number of clouds over Antarctica. I'd probably get a lot of clouds, even if there aren't a lot of clouds. So that algorithm isn't the best algorithm. It's the one that we're going to be working with this week, but something that you might do in your projects, if, say, you choose something like this as a group to do a project, is to come up with a more advanced algorithm that was a little better.
Or one of the better ones, like using neural networks?
Absolutely. So we're going to have a little section kind of towards the end on what's called artificial intelligence or machine learning. And we're not going to have to write machine learning code from scratch. That is a whole course in college, which I can point you to textbooks, and they're fantastic. But what we're going to do is work with some existing software that will help us use artificial intelligence or machine learning to do tasks. And people are applying those techniques and those algorithms to everything from health data. One of our speakers is from a company called Delta Brain, which works with health, and his company uses machine learning, some of the algorithms that we'll learn how to work with, to automatically diagnose lung cancer better than humans who have been trained at it for 8 years or more, 10 years, 15 years, experts in this. So what these sort of software packages and algorithms and techniques are very good at doing are spotting patterns that maybe even humans can't see. So figuring out what has a cloud and not might be a good technique. This week we're going to work with a very, very simple technique, but just know that we're going to learn all the skills throughout the course to be able to do more advanced things and approach things like this that scientists actually need to know, and they can't hire someone to look at every 115-mile square piece of the Earth every 16 days, because just literally there aren't enough people around to be able to do that and to do that reliably. A machine, once you figure out how to program it to do so, can do that quickly and reliably. Yeah, so that's a good point. So self-driving cars are also using machine learning techniques, computer algorithms that learn automatically how to recognize patterns, because you really want to tell if something is a shadow or if it's a kid, if you're a car. Because you don't want to put on your brakes at 60 miles an hour if it's a shadow, because that's going to hurt the person inside the car. But if it's a kid, it's maybe worth the person inside the car getting a few bruises or even a broken bone if you're not literally killing another human. So you really have to be able to do this robustly. And the hope is, and they're already sort of seeing this, that eventually the cars will be better at doing this than even us as humans are. So I just gave you a little overview of what we're going to learn today, and we're going to see more this afternoon. I don't want to talk too much. The good news is that all this information is in the textbook. So as you go through the lab, you can read through the textbook and kind of skip over stuff you recognize already, but also when you get to new material, it'll tell you when you're ready to do different parts of the lab. So what we're going to do now is take a little bathroom break. There's bathrooms right outside to the left, and I'll show you where those are. And then we're going to go across the street and plug in our computers and get set up in our lab, install some software, and get started there. So the bathroom break will be like 5 minutes, and then we'll all meet right outside here. Oh, I should ask, sorry, before we get up, are there any questions on this section? We'll have a lot of chance to chat in the lab, but if there's a question that it might be good for me to show, let me know, because it'll be taped, so then you can have the answer later. Okay.